We'll start this lesson by reviewing adding fractions. Remember that you can only add fractions that have a common denominator. It's like saying you can only compare how many slices of pizza that you've eaten as long as everybody has eaten the same size slices. So to get a common denominator, what you really need is the least common multiple of all the denominators. So for 6, the least common multiple, or the prime factorization for 18, and for 12. So when we're looking for LCM, right, we have 2 and 3, a 2 and a 3, a 2 and a 3. We have a 3 here, and 1, 2 there. So the least common multiple on this is 36. So in order to get a denominator of 36, we had to multiply 12 by 3, which means we have to multiply the numerator by 3. For 18, we had to multiply by 2, and for 6, we had to multiply by 6. So now, all of our pizza slices are the same size, and we can compare how many each person has eaten. 30 plus 34 is 64, and 64 minus 21 is 43 36. The same rule applies when we're dealing with polynomials. Here, if we're looking for the least common multiple, of 6a squared, so we start with the first one. We had a 3. We have an a there. We put in those two b's, which means we use that one up. So we're left with 6a squared b squared. That's going to be our common denominator. So on this first fraction, all I need to do is multiply by b squared over b squared. On the second one, I need to multiply by 2a squared and then on the last one, I need to multiply by 6ab. When I combine these, I end up with b squared plus 2a squared minus 12ab over 6a squared b squared. This numerator can't be factored, nothing can be canceled out, so that's the final answer. Sometimes you have these kind of instances where there are no common factors, so really your common denominator ends up being the product of the two terms. So on the first one, you would multiply by y over y. On the second one, you'd multiply by y squared plus 1 over y squared plus 1. You get 2y plus 5 in parentheses y squared plus 1. Again, this numerator can't be factored, so this is a simplified answer. These problems do get quite a bit more complicated because now we have to factor the first denominator Here are my factors, the second one. So if I'm looking for least common multiple, this is a mistake, those aren't squares. Then what I see is I have a y plus 1, a y minus 2, and a y, because this y plus 1 already exists. So at this point what we do is we look at each one of these denominators factored and figure out what else we need. So this denominator factored is this, which means the only thing extra I need is this y, so I can multiply by y over y. This denominator factor is this, so all I need is the y minus 2. So I end up with y plus y minus 2 over y times y plus 1 times y minus 2. And I can simplify that numerator. And that's simplified. This is one of my favorite problems because it's so simple and it just looks so incredibly complex. The first thing I want you to notice is all of these denominators. This one and this one are the same, which means I can combine this fraction and this fraction. And then these denominators are the same, which means I can combine these. So simply rearranging will help simplify what's going on. So we have a plus b over a minus b minus b minus a over a minus b plus a minus b over a plus b plus b minus a over a plus b. So all I did was rearrange, but now I have some common denominators happening. You all will make this mistake if you don't pay attention. That b minus a is in parentheses, and you have to distribute the negative sign. So you have a plus b minus b plus a, all over a minus b. Then you have a minus b plus b minus a, all over a plus b. So positive b minus b is equal to 0. A plus a is 2a. Negative b and positive b is equal to 0. Positive a and negative a are also equal to 0. So your numerator here is 0. And 0 over anything is just 0, which means your answer is this. Final problem, and you're very likely to see this very often. Looking at your denominators, you should notice that 2 of them can't be factored, but the last one is actually a difference of perfect squares. So we can factor that one to be 2u minus v times 2u plus v. And that is actually your least common multiple. So as you go back and look at these other fractions, what do you need to multiply by this to get this? Well, it's just 2u plus v. And you would do the same thing here. You just need to multiply by 2u minus v. So then when we do that, we end up with 3u times 2u plus v minus 2u times 2u minus v plus 2v squared, and it's all over the common denominator, 2u minus v times 2u plus v. And now we simplify. Pay attention here. Negative 2u times negative v is positive 2uv. Combining like terms, 6u squared minus 4u squared, that's 2u squared. 3uv plus 2uv is 5uv. And then 2v squared. And then to factor, and this is factorable. Now I know we normally want to say, oh, we've got a u squared and a v squared, perfect square, but 2 is not a perfect square. So this is actually not a perfect square trinomial. Instead, I think of it as 2u times u and v times 2v. So this becomes 2u squared plus 4uv plus 5uv plus 2v squared. And that's all over 2u minus v times 2u plus v. Those cancel. Final answer, u plus 2v over 2u minus v.